Hello everyone. In this video we will discuss about the Chatellier's principle. This is a pretty simple concept. If you just focus on this particular figure, then your whole understanding would be super easy. So let's say this is let's say this is two water tank, and there is a connections right in between here, right at the center. So this is two portion of the water tank. There is a tap right here, there is a tap right here, and you can add water from the from the top and from the bottom here. So you guys get it. So we have two taps, one on the bottom, one on the top, one on the top and one on the bottom, and also there is a connector in between. So let's say, so there is a connector right there. So let's say you dump some water to the left side of this tube. What's going to happen once I open this tab right here? All the water, they're gonna flow to the other directions. Eventually what's going to happen, you will reach to an equilibrium positions. So let's say that equilibrium position is achieved, and it happens something like this. Okay, so right now the water level are equal on both sides. So now think it this way. What's going to happen if I add more water to the left? So if I add more water to the left side, so if I add more water to the left side, what's going to happen? Obviously water will flow back to the other side and you will reach to the equilibrium spot. So you will reach to the new level of water, which is here and here. So again they will be balanced. So it doesn't matter if I add more water to the left side or more water to the right side. So if I add more water to the left side, the water level will increase on the right side. If I add more water to the right side, obviously the water level is gonna go again on this side. Now think it another example. Instead of adding water, what if I release my tab here? So I open this tab right here, and I let some of the water go from this side. What's going to happen? Even if I water is letting go from this side, the water level is also gonna drop from the left side. So I open the tap on the right side, the water level has to drop from the left side. So that's the idea behind what Chatellier's principle tells us. So if we stress a system that is in equilibrium, how it would behave. So that's all is about. So if we stress a system, so let's say we have a system that is A is in equilibrium with B, right? So if we add more A to this equilibrium, the equilibrium, as soon as you add more A, suddenly the rate of reaction will change and the stops will start moving again back towards the B. So once you add more A, equilibrium will shift towards the product, which is to the right side. So it's called shifting to the right, or you can call it shifting to the product. So if I add more A here, it will move the equilibrium to the right side. While on the other side, in another example, if I add more B, what's going to happen? Equilibrium will shift to the left. So that is shifting to the left, or shifting to the reactant. right? All right. Okay, so what if instead of adding, I remove some of the B? So what happened if I remove some of the B from here, like just like the water, I open the tap from this side. What happened to the other side? The water dropped because the water flows from left to right. So if I remove B, so if I remove a little bit of B, then the equilibrium will be flowing to this side, to the right side. So equilibrium will shift to the right. So you have to maintain the balance. So equilibrium has to maintain the balance. So if you remove the B, immediately some of the A would convert back into B to maintain that balance. So the same thing will happen if you remove A. So if I remove some of the A, some of the B would change back to A to maintain that balance. So shift to the left or reactant. Are we good? Uh, so again, consider is a two water tube, like two water tank connected through a connector, and you have everything, one on the top, one on the bottom, inlet and outlet, inlet and outlet. What would happen if I open one of the tap or add more water from the another tap? Which direction the water will flow? So again, quick recap. If I more water here, the excess water will flow to the right side. Good. If I add more water to the left side, the excess water will flow to the left side. If I release, if I release some water from the left side, the water will flow from right to left to make it balance. Again, if I release water from the right side, all the excess water will flow to the right side to maintain the balance. So if you understand this principle, it's gonna be extremely easy. Okay, now let's see what would happen if we increase the temperatures. So in some reactions, you get heat from the reactions, and in some reactions you have to heat to do a reaction. So let's say if you have a reactions that looks like this. C plus D. So in this case, these reactions need heat. So on the reactant side, to do this reaction, you have to heat it up. Just like if you want to activate your yeast, you have to warm your water a little bit, right? So in this reaction, heat is an ingredient. So if heat is an ingredient in a chemical equilibrium, so just imagine this way. Consider heat as a reactant, then your life would be way simpler. So adding heat, or you can say increasing temperature is equals to adding heat, right? So it's almost means adding heat. So what's gonna happen if I add some more heat? My equilibrium will shift towards right side. So the equilibrium will shift. So this means I will produce more C and more D. Equilibrium will shift to the right, or you can call it product. What if instead of increasing temperature, I decrease the temperature? So if I decrease the temperature, that means all I'm doing is I am removing heat. So if I'm removing heat, that means it's gonna equilibrium. So if I'm removing this one, like if I'm opening this type, so water should flow from right to left, right? So this means equilibrium will shift to the left, or reactant. So because this reaction heat is being added, so this is called endothermic reactions. So this is called endothermic reactions, because this reactions, in the forward reactions, it needs heat. So that's an endothermic reaction. The forward reaction is endothermic reactions, but the backward reaction is called exothermic because it's releasing heat. So maybe we can have another example and have a practice. So when I say pause the video, you should pause the video, write down the answers, and then unpause the video. Okay, so let's say we have another reactions. X is changing to Y plus heat. So this is an example of exothermic reactions. The forward reaction is exothermic because the heat is being produced. So like think it this way, what is an example of exothermic reactions? You are burning fire, so that's an example of exothermic reactions. Okay, so let's say the equilibrium is achieved and the forward reaction is exothermic and there is a backward reactions. So in this case, if I increase the temperature, which means pretty much same as adding heat, so what would happen? Pause the video right here. Now I'm gonna give you the answers. Okay, so the answer is if I add heat, so if I add heat here, like if I add water here, obviously they're gonna flow to the left side. So adding heat on this particular example is gonna move, it's gonna shift the equilibrium to the left. To the left, or what should we call it? Left is reactant. Okay, so let's do another practice. So what if instead of adding heat, we we decrease the temperature. Decrease the temperature. So decreasing the temperature means almost equals to removing heat. So think it this way. If I open a tab here, what's going to happen? The water will flow from the left side to right side to make things balance. So the equilibrium will shift. Oh, I meant to put equilibrium will shift to the left side here. So equilibrium will shift to the right side, which is right side is product. It's pretty simple concept. Once you get used to it, it's gonna be pretty simple. Okay, so this is about the temperature. So now we're gonna look at what would happen if there is a change in number of moles. So number of moles is also similar. So let's see. So effect of volume. This is what I meant. Effect of volume. So let's look at this reactions. 2CO is reacting, which is carbon monoxide, is reacting with oxygen to give you carbon dioxide. Equation is balanced. Okay, so these are all gases. Okay, okay, so these are all is our gases. So can you tell me how many gas molecules we have on the left side? So we got 2 moles here and 1 moles here. So we have total 2 plus 1, 3 moles total. On the right side, how many moles we got? 2 moles. So if you remember from gas law, each mole, no matter the type of gas, each mole occupies 22.4 liters, right? So for each 1 mole equals to 22.4 liter. 22.4 liter at standard temperature and pressures. So that's the molar volume. So think it this way. So you have 3 moles of gases are packed in a small volume, or 2 moles of gases packed in a small volume. Which side will be happier? Let's say volume is small. Obviously the side on this side where you have lesser number of people, like think it this way, you have more people packed in a small room or less people packed in a small room. Who would be happier? Obviously less people, right? So when you decrease the volume, when you decrease the volume, so who would be happier? As you decrease the volume, the side that has the lesser number of moles is going to be happier, so the equilibrium will be shifted towards the right side. So shift to the right. So you are compressing to make smaller number of particles. Shift to the right or product. So when I say right, right means for this particular example. So you should shift the equilibrium to the side that has the lesser number of moles. So maybe I should write that down. To the side that has lesser number of moles. All right. Okay. So if we opposite would happen if you increase the volume. If you increase the volume of your reaction chamber, it will bring the equilibrium to the left side for this particular example. So shift to the left, which is reactant, or you should say to the side that has more number of moles. Okay, so I think these are some of the critical concepts from the Le Chatelier's principle. We will be using this more often in the futures.